All right, welcome to the Explainer. Today we're jumping into something it's a huge shift in how we build software and even how software acts. I'm talking about the rise of AI agents. This is all about moving past the simple chatbots we've gotten used to and into systems that can, actually do things.
So let's just park on this for a second, because this quote from the source white paper, it absolutely nails the huge leap we're talking about. See, it's not just about making a language model smarter, it's about letting it out of the box so it can become an active player in our digital world.
For a while now, we've all gotten pretty used to the model on the left, right? You type in a prompt, you get text back. Simple. But what an agent does, that's a whole different ballgame. Look at the diagram on the right. That's the secret sauce. This dynamic loop of thinking, then acting, and then crucially, observing what happened. And that's what lets it go from just talking about something to actually doing it.
Right. So this whole section is about one big idea, moving the brain out of the box. For so long, AI has been this incredibly smart but, passive tool. It's been stuck. Agents are what finally give that brain a way to reach out and actually act on the world around it.
Okay, so how does this actually work under the hood? It really boils down to three key parts that you can think of kind of like a living system. You've got the brain, you've got the hands, and you've got a nervous system connecting everything.
So first up, you have the model. This is the brain of the whole operation. It's the core language model, like a Gemini, that's doing all the heavy cognitive lifting, the reasoning, the planning. It takes a look at the goal, figures out the steps to get there, and decides what to do next.
But, a brain on its own can't really do much, right? It needs a way to interact with the world. And for an AI agent, its hands are its tools. Now, these aren't physical hands, obviously. We're talking about things like API connections, the ability to run a search or query a database. These are what let the agent grab live data and take real concrete actions, like, say, booking a flight or checking on your order. And that brings us to the final piece of the puzzle, the orchestration layer. You can think of this as the nervous system. It's the code that connects the brain to the hands, making sure they work together. It's managing the whole show, executing the plan the brain comes up with, keeping track of what's happened in its memory, and running that all-important think, act, observe loop over and over.
So here's the really crucial thing to get. It's how all these parts work together. This isn't just a one-and-done command. It's a continuous cycle, a loop that lets the agent figure things out and solve problems all on its own.
And that cycle pretty much always follows this basic 5-step process. First, it gets its mission, the goal. Then it scans the scene, asking itself, okay, what tools do I have? What do I already know? Next, it thinks it through, creating a step-by-step plan. Step 4 is taking action, using one of its tools. And finally, it observes the result of that action, which then feeds right back into the top of the loop for the next cycle of thinking.
Let's make this real. Think about a simple question like, where's my order? Now, a standard chatbot might just guess based on old training data. It doesn't know. But an agent, it uses that loop to execute a full-blown plan. First, it'll think, okay, I need to call the internal orders database to find this person's order. It does that and observes the result. Aha, I've got a tracking number. Then it thinks, next step, call the shipping company's API with this number. It gets the status back, and only then does it report the final, accurate answer back to you. See the difference? It's huge.
Okay, so that's a single agent. But now, let's see how this whole idea really starts to scale. Because as powerful as one agent is, when you get to really complex tasks, they have their limits. Just like in the real world, sometimes what you really need is a team.
So what actually happens when you try to get one single agent to do everything? Research, writing, editing, fact-checking, the whole shebang. Well, you end up with this massive, monolithic, do-it-all system. Its programming and its prompts become incredibly complex, which makes it a nightmare to debug and honestly pretty unreliable.
So the solution is actually pretty intuitive. You start to think like an organization. Instead of building one giant, clunky agent, you build a multi-agent system. Think of it as a team of specialists. You have one agent that only does research, another one that only writes, and a third that only edits. Suddenly, each one is way simpler, easier to build, easier to test, and the whole system becomes way more powerful and reliable.
And just like any good human team, these agent teams need strategies to work together effectively. So developers are creating different kinds of workflow patterns. You can think of them as playbooks to coordinate how all these different agents collaborate.
And this table here breaks down some of the core playbooks. For instance, you've got the LLM-based coordinator pattern. Think of this as using one big language model as the project manager, who looks at a task and dynamically delegates it to the right specialist agent. For more predictable jobs, you might use a sequential pattern. That's basically an assembly line, where work gets passed from one specialist to the next in a fixed order. If you need speed, you go with a parallel pattern, which lets multiple agents work on different parts of a problem all at the same time. And for jobs where quality is everything, you can use a loop, which allows an agent to critique its own work or another agent's work and keep refining it until it's perfect.
So, the big takeaway here is that these aren't just programming tricks. These architectural patterns represent a really fundamental shift. We're moving away from a world where we have to write every single line of code, every piece of logic, to a world where we design systems of autonomous agents that we can just guide towards a goal. It's a completely new way of thinking about how to solve problems.
So where is all of this ultimately heading? Well, the frontier of this tech is, frankly, pretty mind-bending. The source white paper talks about something called Level 4, a self-evolving system. We're talking about an agent system that can actually look at its own performance, identify gaps in its own capabilities, and then, get this, create brand new tools or even spin up entirely new specialized agents on the fly to fill those gaps.
And all of this leaves us with a final, really big question to chew on. As these systems get more autonomous, more collaborative, and even start improving themselves, are we just building better, more efficient software? Or are we, maybe, in the process of creating something else entirely? A genuinely capable, uniquely adaptable new member of the team?